Hi guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, the BYJU'S Exam Prep. And yes, I Rakesh Sir once again welcome you all to this concept classes of digital electronics. Yeah, I've been telling you that sequential circuit parts, one of the most crucial chapters in the digital electronics, the chapter where questions are guaranteed to come, the chapter where students faces a little bit difficulty, otherwise all other chapters of digital are easy going. And to have a good understanding and good command on digital electronics, it is very much essential to be clear about the concept of latches and flip-flops. And that is why we are eyeing the concepts of latches and flip-flops on these days in our classes. Very good evening all. Keep joining the sessions. Keep sharing the session with your friends, juniors, colleagues, whoever might be, preparing for the GATE or engineering services or any other technical based examination. Very, very good evening, guys. Very, very good evening. Keep joining. Okay. Yes, so let's learn about race around condition and the master slave flip-flop. So what we were doing, let's have a quick review of what we were doing in the past two classes, and then let's move ahead towards our next intent. Very, very good evening. Very, very good evening. Keep joining. Hey, good evening, Geeta, Rajesh, Navneet. Okay, let's get begin up, guys. In case somebody new to my session, this is a brief intro about me. This is your mentor and educator, Rakesh. I have secured All India rank 9 in the GATE examination, completed my masters from the Indian Institute of Science, Bangalore, and trained more than 50,000 students in my more than 11 years of teaching experience. I commonly deal with control system, digital electronics, signal and system, and electromagnetic theory in the tech domain. And other than that, I also deal with the maths and aptitude in the general domain. Right. Instrumentation, applied physics. Have you got it, Omkar, for MSc or regular course? Good evening, Ruby, Akhtar. Very good evening, all. Keep joining the session. Yes, this is the Hall of Fame, the BYJU'S Exam Prep students outshined in the GATE 22 examination. Tremendous results, All India rank 1, 2, 3, and many students secured All India rank under 100 in the GATE 2022 examination. Right. Yes, guys, so in case if you're preparing for GATE 23, GATE 24 and you want to enroll for the GATE preparation programs by BYJU'S Exam Prep and you want some financial assistance, so yes, prove yourself in the scholarship test that is coming up on this Sunday, okay, 1st of May at 11 a.m. right, and you can get a chance to avail up to 90% scholarship on the GATE preparation courses, right? Yes, I told you yesterday also, guys. Yes, it's the digital era. Most of us, most of the students are studying online, right? For the past 2 years, the digital world has evolved and it's been so dominating. It's good that you are able to study sitting at your home and able to study any type of content, whatever you like. You are able to select your best educator, but at the same time, this also might be putting little bit stress on your health. So if you are feeling little stress and anxious, okay, in this digital era, right, what are the ways to overcome it? Let's have a discussion, right, because we just keep studying and neglect our health and other psychological factors that is important. So let's discuss this Saturday at 10 p.m. the stress and anxiety that is caused by digital age, right, and how to deal with it. There are definitely problems there, and there is also a solution to every problem. So what could be the possible solution? A few suggested tips from my side. Okay, guys, let's keep moving ahead. Right, for students it is a digital world, for teachers it is a digital world. We are also working day and night in front of laptop or smart screen, totally surrounded by digital gadgets only, right? So how to maintain a good balance between work and the health. Similarly, for a student, how to maintain the good balance between the preparation and the health. Both should be on the right track, right? Thank you, Rajesh, and congratulations for All India rank 153 in ECE. Hope you get your desired branch or PSU, whatever you are willing for. MTech Research, Omkar. Okay, yeah, so I'll just come back to you, Omkar, or you can message me personally on Telegram. Otherwise, I will, deviate from my topic, Omkar. So just post me on Telegram. Probably tonight or tomorrow morning itself, I'll try to respond to your query on the Telegram. Okay, this is what is the series going on. We have already discussed this, so you can just take a screenshot in case if you are new to the session. This is the sequence of classes I'm taking. Tomorrow we'll have the flip-flop conversion and the state transition diagrams, commonly known as the state diagrams, and flip-flop waveform based questions will be discussed in the upcoming 3 classes. The daily routine is for digital electronics 8 p.m. That is fixed. Continuous daily 8 p.m. Right? Continuous daily 8 p.m. Now guys, what we have studied in the past 2 days? Okay, we first started with the unclogged SR latch. A quick review, right? The unclogged SR latch, which was asynchronous, which is an asynchronous category of circuit, right? And we found that there can be some stability issues, there can be noise issues in the asynchronous circuit, and that is why we went towards designing synchronous circuits. We started with the clogged SR latch. After discussing of the clogged SR latch, now that was the fundamental. SR latch is the fundamental, and small modifications in the SR latch we're able to design different type of latches. So we then move towards the clogged D latch. Then we next move towards the clock JK latch. Now JK latch, we know that in the SR latch there was a problem. The problem was the problem of invalid states. You cannot make both the input S and R high at the same time, otherwise the device goes into invalid state. What is the problem with invalid state also we discussed in these classes, right? So the problem of SR latch was eliminated by 2 persons, Jack and Kilby, right? They were the inventors of JK latch, and then this latch was named as JK latch, Jack and Kilby, right? And shorting both the inputs of JK latch, we eventually came up to the T latch, right? Why D latch is known as D, why SR is SR, why T is T, all those things also were discussed conceptually. Okay, so this is what we have discussed. Now in the latches, what we are discussing clogged latches. Acha, what type of clocking we are looking into, guys? Everybody, if you have followed this, we have been following level triggered devices. The clocking that is applied right now is the level triggered type of clocking. Level triggered means the circuit will respond to a particular level of the clock. For example, level 1 of the clock. Whenever clock is at level 1, the circuit will respond. Otherwise, circuit will not respond. Circuit will block the inputs and it will retain its original state. Okay. Now, what is the problem with level triggered circuit? Let us try to understand with the help of JK latch. Let us try to understand the problem known as the race around condition. Okay. Now, this is what is the clogged JK latch. Yesterday we discussed this. I hope you are able to remember it. Okay. If I just give a quick review, this is what is the unclogged SR latch. This portion is the unclogged SR latch, also known as the NOR gate latch. The unclogged SR latch, also known as the NOR gate latch. Okay. Then we introduced the clocking in the SR latch with the help of 2 AND gates, and the clock pulse was provided. And then one more level of feedback, the clogged SR latch was converted to the clogged JK latch. Now this is how it functions, what is the various state transitions in the JK latch, everything we have studied. Now let us move towards discussing an important area here, a race around condition here. Before we discuss that, let's all quickly review कि whenever both J and K are equal to 1, whenever both the inputs to the JK latch are high, what happens to the latch? The next state of the latch will be complemented or toggle of the current state. Usually I call the current state as Q and the next state as Q plus, as you know, plus for the next state. So Q plus is equal to the Q bar, and we were calling it as toggle state. Or complement state. So whenever both the inputs you make high, the device gets complemented. Now let's say that you have a latch which is initially reset. There's a latch, JK latch, which is initially reset, and you would like to complement it. You want to toggle its state. Now as soon as I tell you that you want to toggle the state, you know what input combinations you will apply. You will start applying j and k equal to 1. If you apply j and k equal to 1, the device get toggled. But is it really the case that you just apply the input j and k equal to 1, the device will be toggled? No, na? Because what we are studying is the clogged circuits right now. Okay, they are not flip-flop. I am talking about a clogged latch. But at least the clogged SR latch will only accept the input when its clock level is 1, assuming level 1 triggered. So ऐसा नहीं है कि you just make j and k equal to 1 and the device gets toggled. No, the inputs will only be accepted once the door opens, and door is level 1 of the clock here. Okay, the door is level 1 of the clock here. Look at this picture. So what I'm doing here is j and k, suppose initially 0, and now I make j and k equal to 1, but I'm telling you again, j and k equal to 1 does not mean that the output will toggle immediately. Okay, the input will not at all be accepted unless the door opens, and door here is the level 1 of the clock. The door here is the level 1 of the clock. So what is the output? Output is Q, which was initially reset, and it will remain to be reset unless and until the door opens. The first thing is let the door be open, and when the door opens, just a second. When the door opens, then only the device will see what is the input. Whatever is the input, the device will accept and produce the output. Will it produce the output immediately? Suppose the door opens and input are ready. Will it produce the output immediately? Will it produce the output immediately? No, na, because even you apply j and k 1 here, clock also opens, that means clock pulse is also 1, q was 0 initially, q bar is 1, so this 1 comes here, this 0 goes here. Okay, so the output of the first AND gate doesn't change. Suppose it was 0, so it remains to be 0, but the output of the AND gate, which is numbered 4, it becomes 1. Because this is 1 into 1 into 1, the output of AND gate is 1. So there will be a certain time involved which is equal to the propagation delay of the AND gate. Now, whenever the input to any NOR gate is I, its output becomes 0. So this becomes 0, but this will become 0. This will become 0 after the delay of NOR gate. This will become 0 after the delay of NOR gate, right? Now this 0 runs here, goes to the NOR gate number 1. Both the inputs of the NOR gate number 1 are 0, and the 0-0 combination will produce the 1 output. The 0-0 combination will produce the 1 output. Will produce the 1 output. Okay? Will produce the 1 output. That is how the device will be toggled. It was initially 0, now it becomes 1. But for the device to be toggled, the signals will propagate through the combination of AND gates and NOR gates, and there will be a total propagation delay of the latch. There will be a total propagation delay of the latch, right? Let's say the TPD of the latch, which is also known as T clock to Q. Now, what is the meaning of T clock to Q? We know that normally the delay in a circuit is known as the time between the application of input till the production of output. But here input to आपने apply कर दिया, but when is the input accepted? The input is accepted only when the door opens. So we have to measure the delay from the point when the clock goes 1, when the door opens. So once the door opens, after how much time the output is produced, that is known as the propagation delay. Input to आप कितना पहले भी 1 कर दो, doesn't matter ना. So the door has to open, and when the door opens, whatever is the input is accepted and the output is produced. So the total propagation delay of latch or flip-flop will be defined as T clock to Q. Okay, let's assume, okay, as I told you, the total delay will depend upon the delays of AND gates and NOR gates. Let's assume a random figure right now. Let's say the T clock to Q or the TPD for this particular latch, rough figure I am taking 8 nanoseconds. Let us take it as a rough figure that is equal to the 8 nanosecond. That is equal to what? That is equal to the 8 nanoseconds. Okay. Let us take it as the 8 nanoseconds. Okay, guys. Now this is the point where my door has opened, guys. Okay, my door has opened, so the output will toggle, but output will toggle after 8 nanoseconds. As I just told you, the difference between clock to Q will be 8 nanoseconds. So this is the moment. इसको mark कर देते हैं. Let me mark this. This is the moment when the door opens, right? 8 nanoseconds after this, 8 nanoseconds after this, the output will toggle and hence it becomes 1. It was 0 and hence it becomes 1. But now, very important thing to be noticed. Very important thing to be noticed, guys, is that output has toggled, but my door is still open. Right, it is a level triggered circuit, and what I explained you in level triggered, level 1 triggered hai, and in this level 1 triggered circuit, up to the time clock is at level 1, the inputs will be accepted and the outputs will be reproduced. Every time an input is accepted, the output is produced. That is what we see here. That is what we see here. That means, look at this case here. Please try to understand this case here, that the output has toggled once, but output has toggled once and the door is still open. Because the door is still open, the inputs is still accepted, and what you did blindly, you just made the input JK1 and left it, and you left it. So what is the current state of the input now? It is still 1 1, right? It is still 1 1. Now look at this point of time. Here also, look at this point of time. Here also the input is 1 1, and JK11 means output should again toggle. Because the inputs are again ready, there will be one more output, that is again the toggled output. So what is the toggle of 1? 0. So now the state, the latch will again toggle and it will be converted to 0. It will be converted to how much? It will be converted to 0. Okay, now how much is this time period? Let me write down. What is this time period? This is 8 nanosecond, the delay of the latch. How much is this? This is also 8 nanosecond. Right, so total kitna ho gaya? The total is 16 nanoseconds. Up to this point, what is the total? Is 16 nanoseconds. And you see the clock, I have made the clock level 1 equal to the 20 nanoseconds. Right, clock is at level 1 for 20 nanoseconds. That means again at 16 nanosecond, the door is still open. The door is still open. So inputs will be still accepted. And if the inputs are accepted, the output will again be produced. So what is the current state of the output now? 0. It will again try to toggle and become 1. But what is the time required for toggle? The time required for toggle is another 8 nanoseconds. So 16 plus 8, 24. We don't have the time up to 24 because at 20 nanoseconds the clock, the door will open, and that operation will not be successfully completed. That operation will not be successfully completed. Right, that particular operation will not be successfully completed, and hence the device remains in the 0 state. Now think from a user point of view. Everybody think from a user point of view what is happening. From the user point of view, the user saw that output is initially reset. Finally, what he sees, user has done everything. He has applied the JK inputs 1, he has given the clock to the circuit. But what is the end result that the user is looking into? The user is looking into that output is still reset. User will think that there is some problem with the circuit is not working, or the circuit is not responding. Something like that user can think, no, the circuit is not responding, the circuit is not working. That can come into the user mind. But we being the designers, we being the engineers, we should know that the circuit is actually working. Try to think, is it the case that circuit didn't work? I explained you with the flow. I clearly explained you with the flow that how this JK1 will produce the output which is toggled of the previous state. The circuit is actually working. The reason actually circuit worked twice. Actually, the time required for one toggle is 8 and circuit did double toggle, 8 plus 8 up to 16 nanoseconds, door was open and the circuit worked, but it worked twice. That is why 0, when you do double toggle, guys, when you do double toggle, 0 becomes 0, 0 to complement 1, 1 complement becomes 0. That is what it is. 0 complement to 1, 1 complement to 0, that is what it is. Isn't it, guys? And hence, finally the output doesn't look to be toggled. So the circuit works, but it actually works twice. Now, what is this problem actually reflecting and what is this problem actually known as? Look into this. Dhyan dena. Right. Let's suppose the time when you apply the clock, where is that diagram? The time when you apply the clock, this is known as this particular time. Let me write it by some different color. Let's say this particular time is t equal to 0, right? And this is the time which is t equal to 16 nanoseconds, right? So at t equal to 0, the door opens. That means the clock becomes 1, right? At t equal to 0, you apply the clock becomes 1. J and K were applied 1 1. The time required by the latch to toggle is 8 nanoseconds as a reference example, right? Okay, so as soon as you open the door, it takes a total of 8 nanoseconds. Output was initially 0, it becomes 1 after 8 nanoseconds. It takes a total time of 8 nanoseconds to toggle the output, but the door is still open, and because the door is still open, this poor signal will again run back and come to the AND gate. Look at the flow, guys, right? This will again come and run to the AND gate, right? Okay, now what is the value of it? 1. K is already 1. Clock pulse is also 1. So output of this AND gate becomes 1. Because the output of the AND gate becomes 1, the input of the NOR gate is 1, and any input of the NOR gate 1, output becomes 0. So that is why double toggle happens, na? Okay. So this clock pulse is active up to 20 nanoseconds. This clock pulse is at level 1 for 20 nanoseconds, but only after 8 nanoseconds the second variable runs and comes here. Suppose if the clock, the second variable runs and toggles at 8 nanoseconds. What is the time required for another toggle? 16 nanoseconds. First toggle at 8 nanoseconds, second toggle at 16 nanoseconds. Second toggle occurs at 16 nanoseconds. Suppose that rather than 20, I close the clock. I close the door at 10 nanoseconds. I close the door at 10 nanoseconds, then there will not be the problem. Okay, because if the clock becomes closed, because the clock becomes 0 at 10 nanoseconds, so there can only be one toggle, na? Time required for one toggle 8 nanoseconds, that is less than 10. Time required for second toggle 16, but that is much greater than 10, and second toggle will not be completed. It may be initiated but not completed, and hence there will be only one toggle which a user wanted. So it is actually looking like a timing race. Try to understand. It is actually looking like a timing race between what? The timing race between the clock pulse, when the clock pulse will become 0, and the variable which is around, the output variable, the feedback variable. Because it is looking like a timing condition, a timing race between two variables, we call it as a race current condition, race around condition. See, normally what is a race condition? Race condition is a condition that we can study separately. Right now I am just focusing on race around with respect to latches and flip-flop. Race condition is studied separately in terms of logic gates and combinational circuit. Race condition is a condition where two inputs to the circuit are in a race to change the output, of the circuit. Here also two variables are in a race. To change the output of the circuit. But which are the two variables? One is the clock pulse and one is the variable which is coming around the circuit. One is a variable which is coming around the circuit. One is a variable which is a feedback signal, and hence we modify the name and we call it as race around condition. Race between clock and the output variable, around variable, the variable which is coming around the circuit, and we call this situation as a race around situation. We call this condition as a race around condition. Now sir, if there is a race around condition, how should I overcome the race around condition? If there is a race around condition, how should I overcome the race around condition? One of the simple logic I already explained you. What was one of the simple logic? Ki clock is going off at 20, make the clock go off at 10 nanosecond. That means, look into this waveform again. Okay, the clock is going off at 20 nanoseconds. Matlab, what is the time period of the clock? 20 is on period, 20 will be off. So time period will be total 40. Time period will be 40. Time period means the time for repetition. So the next level one will come after 40 nanoseconds. Let's say change the time period of the clock and make it as 20 nanoseconds. If the total time period is 20 nanoseconds, so level 1 will be for 10 nanoseconds. If the total is 20 nanoseconds, then level 1 will be for 10 nanoseconds, and then double complement will not occur, only single complement will occur, which you guys want. Right? Alright, so that means one method of overcoming this problem is to change the time period of the clock. But there is a problem here. This is not a very good solution. This is a solution, but this is not a very good solution. I will explain you why. I will explain you a simple logic. Suppose that, okay, you have this JK latch. right, where you have applied this clock pulse. You have applied the clock pulse to the JK latch, right? But later on, right now we are only studying latches and flip-flop. Later on, you also go and study the entire sequential circuit, which may contain various flip-flops, which may contain various other blocks. What are those other blocks that you will understand? It may contain counters, it may contain registers and multiple things. So there is another circuit. There is another part of the circuit, right? That also uses the same clock. That also uses the same clock, right? This is another part of the circuit. This is another part, right? Suppose the TPD, the T clock to Q for this flip-flop was 8 nanosecond, and according to the 8 nanosecond, you think that, the time period, according to, just a second, you think that the time clock period should be 20 nanoseconds, so that the on period is only 10 nanoseconds. But suppose that the same clock pulse is connected to another part, and the propagation delay of the another part is suppose let's take 15 nanoseconds. Another part is using the same clock and the delay of the another part is 15 nanoseconds. So that means the time required for this another part to reflect its output, to change the output, is 15 nanoseconds, but you only apply the level 1 for 10 nanoseconds. You only apply the level 1 of the clock only for 10 nanoseconds. Only and only for 10 nanoseconds you apply the level 1 of the clock. Okay. So this circuit will be hurt, na? This may not be able to complete its operation because much before 15 nanoseconds you make the clock off, you close the door, and the operation may not be completed successfully. Okay guys? That means look into this possible solutions. How to avoid this? Okay, the clock must have a time period according to the propagation delay. According to the, there is no relevance of P here, sorry, it's a typo error. The latch must have, the clock must have a time period according to the propagation delay. Oh, that P shifted here. According to the propagation delay of the latch, but this might affect the operation of the remaining circuit. That is why it is not a very feasible solution. It is a solution, but not a recommended solution, right? Another solution is use master slave or edge triggered flip-flops, which will respond only to the transition of clock pulses, not to the duration of clock pulses. Sir, let's go back to the same diagram. Okay, why double complement occurred here? See, I'm not changing the time period of the clock now. Okay, so the time period of the clock is 20 plus 20, 40 nanoseconds. 40 nanoseconds level 1, 20 nanoseconds level 1, 20 nanoseconds level 0. So overall time period is 40 nanoseconds. What happened here? The level 1 is 20 nanoseconds. One toggle occurs at 8 nanosecond. Right. Another toggle occurs at 8 nanosecond. 8 plus 8 is 16. So within 16 nanosecond, double toggle occurs. The problem was that, okay, I don't want double complement. I wanted only one toggle. Why it occurred? Because I'm talking about level triggered circuit, and as long as the clock is at level 1, jab tak clock level 1 pe rahega, as long as the clock is at level 1, the inputs will be accepted and the circuit will respond and produce a new output. As long as the clock is at level 1, the inputs will be accepted, the output will be produced accordingly. That is why this double repeated operation occurred here. Idea is to now design a device which will not respond to this level 1. It will only respond once in one clock cycle. It will only respond to the edge of the clock, to the transition of the clock. Up to this point, we are responding to the level of the clock, and now I want to design a device which will only respond to the edge of the device, to the edge of the clock. The edge can be any type of edge. It may be a positive going edge or it may be a negative going edge. No problem. But design a device which will only respond to the edges, right? Only when the clock makes a transition, the inputs will be seen once, output will be produced. That's it. That's it. Only one time the output will be calculated in one clock cycle, not more than that. But in the level triggered, the output can be calculated once or twice or thrice or 4 times depending on how long the clock is at level 1, depending on what is the clock period of the time. Right guys, so this is the idea, but how to implement this idea, sir? Ye question mind mein aa raha hoga, that is what we are going to discuss. Right, so idea is to now design edge triggered devices. The idea is to now design edge triggered devices, right? Edge triggered devices, and let's start with the design of a master slave flip-flop. So until now we have discussed the functionality of latches which respond during the pulse duration, level triggered. Level triggered. But a flip-flop is a device which will respond to pulse transition rather than the duration of the pulse, right? A positive edge triggered flip-flop can be there, a negative edge triggered flip-flop can be there. What is a positive edge triggered flip-flop, sir? Which will respond to low to high transition, as I was telling you earlier also. Whenever the clock makes a transition from 0 to 1, low to high, then the circuit will respond. Or it may be a negative edge triggered flip-flop. You can design any one of them. Both are practically possible to be designed, right? Whenever clock makes a transition from 1 to 0, whenever clock makes a transition from 1 to 0, from high to low, from 1 to 0, from high to 0, from high to low, then the device responds. Right? Now, how to design it? That is just a little bit theory, but actually how to design it? Let's discuss about the idea. Master slave flip-flop. It is nothing but a cascade combination of 2 JK latches. Now, this is what, let me write down. This is what is known as the master JK latch. Yeah, let me simply write it as the master latch. Okay, this is what is a master latch, and this is known as a slave latch. Sir, why the name master and slave is coming? You will understand if you just know the meanings of master. Now, master is someone who decides and commands. Slave is someone, slave, knocker, gulam, what we call it as knocker or gulam. Slave is somebody who will just follow the commands of master. The slave can't decide anything. The slave can't, calculate anything. It will only copy. It will only follow its master, the commands given by the master, the poor guy, slave. So one is master, one is slave, right? The outputs of master are, suppose I'm calling it as YY dash. These are the external JK input, and this is the clock. Now both the latches are connected in cascade. But the clocking of both is different. Okay, now because I'm calling both of them as latch, so we should know that latch is level triggered. Individually both of them are level triggered. Right, both of them are level triggered, right? So both of them will accept the clock, but one is having the clock, another one is getting the clock bar. One is getting the clock, one is getting the clock bar. The output of this inverter. One of them is getting the clock, one of them is getting the clock bar. Right, everybody? Clock bar, clock bar. Now let us see the operation, what happens. What happens when the clock is at level 1? Try to understand very clearly. What happens when the clock is at level 1? The clock is at level 1, the master will respond and slave will be off. Okay. Master will respond and slave will be off. Achha, forget this. Before I show you this clock levels, first let us all calculate the slave equation. Yeah, let me write down both. What is the master equation? What is the master characteristic equation? Y plus, what is the output of the master is Y. So next state will be known as Y plus is equal to, remember the formula, J Q bar, right? That means J Y bar plus K bar Q plus K bar Y. That is the master characteristic equation. What is the slave characteristic equation? The slave characteristic equation. So actually that should also be same. The basic equation is same, but once I write down the slave, what is the output of the slave is the final output of the device, that is known as Q. Q plus is equal to J. Now what is coming to the J? Let me write it as J Q bar plus K bar Q, but what is coming to the J? Y input. So Y Q bar. What is coming to the K? What is coming to the k is y bar, bar, and then q. So what is the q plus? Y bar ka bar becomes y, so y is common, and then write down q bar plus q. What is the q bar plus q? Is equal to the 1. Q bar plus q is equal to the 1. So this is y into 1, that is equal to y. So what is the q plus? Is equal to the y. That means this equation itself makes us clear that what is the output of the slave? What is the output of the slave? It is y, which was produced by master. So master will compute and produce the variable known as y. The slave will just copy that variable here. And if you are able to recall from the previous two classes that suppose I call this y equal to d, suppose I call the y equal to d, so q plus is equal to y or q plus equal to d, that is the functionality of nothing but a d latch, or a d latch. So this is nothing, guys. This implementation of JK latch converts it into a D latch. Whenever both the outputs of JK latch are toggle off each other, one is y bar, one is d bar, then that latch behaves as then that JK latch behaves as a D latch. Acha, don't worry, tomorrow anyways we are going to study flip-flop conversion, how to convert one flip-flop into another, what is the procedure, what is the shortcut, everything we are going to study tomorrow. Right, tomorrow is all about flip-flop conversion, but just one case anyways I have explained you that the second slave, that is the JK latch, is actually behaving like a D latch, nothing but it is just copying its data which is produced by master. So that is why this is known as slave. That is why this is known as slave. It just copies the command. What is the command? Y of the master. It just copies the command y of the master into output. It does nothing but it just copies, because it's a slave, na gulam hai, naukar hai, wo kuch kar nahi sakta, wo keval follow kar sakta hai. Just copies. It's a slave, poor fellow. Right. Now based on this, let us continue our understanding. Suppose that the clock is at level 1. Suppose that the clock is at level 1. So whenever the clock is at level 1, okay, level triggered devices, clock is at level 1, so master slave is on, but if the clock is at 1, the clock bar is 0. The clock bar is 0. And because the clock bar is 0, the second JK latch is off. Individually the latch is level triggered device. Now the slave is off. The slave is off. So master is on, right? So what it does, it computes. Master is on and it will compute the variable y, but will the variable y, master ne produce to kar diya, master produces the output variable y which is ready here, but will it go to the final output? Will the user see the final output? Not at all, because the final output is transferred through slave and the slave is off. Clock is 0 for slave and the slave is off. Slave is off, so final output not affected. Final output not affected. Sir, if the clock becomes 0, if now the clock becomes 0, so what happens to the master? Master is now off. Master is now off, right? So if the master is off, clock 0 1, look at this. Now the clock is 0, so this is 0, master is off, and because the master is off, it will not accept any more input. But clock bar now becomes 1 and slave becomes on, right? So master is off, so it doesn't accept JK inputs. Okay, but the slave is on. Who is on? Slave is on, right? Slave is on, so what will slave do? What will slave do? It will just copy the master commands into the output. So see, it's a two-stage calculation. In one cycle of the clock, when the clock is at level 1, master will compute, but that time slave is off. When the clock goes 0, then the slave will copy the output, the calculation of master into the output. So when do you see the final output actually? When the user will see the final output, guys. When the user will see, when is the final output getting reflected? When the clock becomes 0. from 1. The clock was at 1, now it becomes 0, and then you see the final output, right? And then you see this final output. When this clock becomes 0, then you see the final output. That means it is a edge triggered device. Acha sir, will the double toggle occur here? What we saw in the earlier case, once the output changes, once the output toggles, it again toggled. Because the door was open and the JK inputs were accepted again and again. But here you see, once the output is toggled, once you get the new output, when do you get the new output? When the slave is on. But at the same time when the slave is on, master is off. Because the master is off, the JK inputs, it does not accept the JK inputs. So inputs are no more accepted and there cannot be a double toggle. Okay, the inputs are no more accepted and there cannot be the double toggle, and hence this is how we overcome the race around condition. This is how we overcome the race around condition. All right. And this is what is simply known as the design of a master-slave flip-flop, which is nothing but a cascade connection of two latches, two JK latches. One is a master latch, one is a slave latch. Both are fed with complemented clocks. Both are fed with the complemented clocks. Right, everybody? Both are simply fed with the complemented clocks, and you see the output. Okay, you see the final output when clock makes a transition from 1 to 0. That means, let me also mention, that means this is known as a negative edge triggered. This flip-flop design was actually a negative edge triggered flip-flop. This was a negative edge triggered flip-flop. A negative edge triggered flip-flop. Okay, everybody, a negative edge triggered flip-flop. Now we'll make small changes in the graphic symbol. This is what is the graphic symbol. Same, it contains two inputs JK, contains two outputs Q bar, but how we were representing the graphic symbol of latch, it was simply represented as CP and there was a pulse. Okay, but here we don't show any pulse because this is not responding to the pulse duration. It is not a level triggered circuit. We simply use this is just a representation. We simply use a triangle type of symbol. Whenever you see the triangle type of symbol, that means it is a flip-flop, not a latch, right? And whenever you see this triangle with a bubble, whenever you see the triangle with the bubble, it is a negative edge triggered flip-flop. So both are the graphic symbols of flip-flop. One is a positive edge triggered flip-flop, one is a negative edge triggered flip-flop. For your reference, I have just shown you the JK flip-flop graphic symbol, but same we can design for the T flip-flop, D flip-flop, SR flip-flop. Okay. So a simple triangle would represent a positive edge triggered flip-flop. A triangle with bubble would represent a negative edge triggered flip-flop. Right, this is what is the graphic symbol, right? And that's it for the this is just the introduction how flip-flop is designed. But now the upcoming 3-4 classes, we are going to talk about the questions and concepts based on flip-flop, how to convert one flip-flop into another, what is the waveform based question, what is the state diagram, everything, and what is all type of questions that you can expect from this topic. So yes guys, a quick reminder that this Saturday, to discuss a very important issue, a very important problem that may be faced by many of the students and everybody, because we are in the digital world right now. It's a digital era and stress and anxiety are dominating on the students' mind. So we have to maintain our health, but at the same time our preparation should be on the very correct track. So what can be the measures taken by us? Okay, so that we don't spoil our health, we don't hurt our preparation. What is a good go? What is the balance between them? Join me live for this very important session, Saturday, 10 p.m. What is my observation and what is a few suggestions that I can offer to you, okay, to overcome this so that your preparation goes on 100% right track. Join me live Saturday, 10 p.m. This is all about the series schedule. So tomorrow we are meeting for flip-flop conversion class. 29th April tomorrow, same timing remains to be same, that is at the 8 p.m. right? So next class tomorrow at the same time of 8 p.m. we are going to deal with the flip-flop conversions, how to convert one flip-flop into another and etc. right? Representation is not the working basically. Representation is just a very irrelevant thing, Sugrita, to mention here. The working, how the latch is clock latches was responding to level of the clock, level triggered devices. Flip-flop is responding only to the edge of the clock, transition of the clock. It is the edge triggered device. So main thing is their functionality, their mode of operation. That is what is the main differentiation between them. Right. Okay, so let's connect tomorrow at 8 p.m. once again. One more important thing I shall update you before going up. So like the last two class PDF, I will share you today's PDF also in the Telegram group. Okay, stay connected in the Telegram group, the alternate Telegram group which I have given you. As I told you, unfortunately my main Telegram group is facing little problem. We are trying to overcome it, but by that time I have given you alternate Telegram link. Join that alternate Telegram link, and the PDF of this session will be password protected. As always, it is only available, the password is only seen if any student is watching this session. The password will be FF, flip-flop@xyz. The passwords are totally random, designed by me. Okay, FF@xyz is going to be the password, right? Okay guys, that's it. Bye bye. Thank you. Stay safe. And if you are enjoying, if you have learned the concepts, if you have understood clearly, do not forget to like the session, mark your attendance, mark your response, like the session. And if you want more such sessions, if you want to attend them regularly, whether it is technical sessions or some generic sessions like we are taking on digital age and all types of sessions, we'll bring you maths and aptitude also in future. If you want all such sessions without a miss, do not forget to subscribe the channel where you are watching this session. Okay guys, so bye bye. Thank you. Stay safe. Take care. Keep learning, keep enjoying, and keep following BYJU'S Exam Prep.